Welcome to this exploration of one of the most famous and mind-bending thought experiments in all of physics, Schrödinger's cat. This paradox has captured the imagination of scientists and the public alike for decades. It elegantly illustrates the bizarre and counterintuitive nature of quantum superposition, where particles can exist in multiple states at the same time. Throughout this video, we'll unpack this fascinating thought experiment and understand why it remains so important in quantum physics. Erwin Schrödinger was an Austrian physicist who lived from 1887 to 1961. He won the Nobel Prize for his groundbreaking work on quantum mechanics, particularly for developing the famous Schrödinger equation. In 1935, he proposed this thought experiment, but here's the twist: he wasn't trying to celebrate quantum mechanics. Instead, he created this scenario to illustrate what he saw as the absurdity of applying quantum mechanical principles to everyday, macroscopic objects. It was actually a critique of the Copenhagen interpretation of quantum mechanics, not an endorsement of it. Let's set up this thought experiment. Imagine a sealed box that completely prevents any observation of what's inside. Inside this box, we place a living cat. Now, here's where it gets interesting. We also include a radioactive atom that has exactly a 50% chance of decaying within 1 hour. Finally, there's a poison mechanism. If the radioactive atom decays, it triggers a detector that releases poison, which would kill the cat. All these components are sealed together in the box, isolated from the outside world. Here's how the experiment unfolds. First, we place all the components into the sealed box and close it completely. Then, we wait for 1 hour without opening the box or observing what's happening inside in any way. During this time, the radioactive atom either decays or doesn't decay. If it decays, the poison is released and the cat dies. If it doesn't decay, the cat remains alive. The critical point is that we have no way of knowing which outcome has occurred until we open the box. Now we arrive at the heart of the paradox. According to quantum mechanics, until we open the box and observe the cat, it exists in both states simultaneously. The cat is both alive and dead at the same time. This sounds absolutely absurd when applied to something as large as a cat, and that's exactly Schrödinger's point. While quantum particles can genuinely exist in superposition, applying this same logic to everyday objects creates this seemingly impossible situation where the cat is somehow both alive and dead until the moment of observation. To understand this paradox, we need to grasp the concept of quantum superposition. Superposition is a fundamental principle in quantum mechanics where a quantum system can exist in multiple states at once until it's measured. In the quantum world, particles like electrons genuinely do exist in all possible states simultaneously. Mathematically, we can represent this with a wave function, shown here, where the cat state is a combination of alive and dead. The radioactive atom is in superposition, existing in both a decayed and non-decayed state, and according to quantum mechanics, this superposition extends to the cat itself. Observation plays a crucial role in quantum mechanics. Before we open the box and look inside, the cat remains in superposition, simultaneously both alive and dead. But the moment we open the box and observe, something dramatic happens. The superposition collapses into one definite state. The cat is either alive or dead, not both. This is called wave function collapse. The act of observation forces the quantum system to choose one specific outcome from all the possible states it was in. This raises profound questions about the role of the observer and the nature of reality itself. It's crucial to understand that Schrödinger never believed a cat could actually be both alive and dead. He thought applying quantum mechanics to everyday, macroscopic objects was absurd, and that was precisely his point. He created this thought experiment to critique the Copenhagen interpretation of quantum mechanics, which stated that quantum systems exist in all possible states until measured. Many people misunderstand this experiment as supporting the idea of quantum weirdness in large objects. But Schrödinger was actually highlighting what he saw as a flaw in how we interpret quantum mechanics. Schrödinger's cat remains one of the most famous paradoxes in physics because it illustrates the measurement problem in quantum mechanics so vividly. The key takeaway is that superposition genuinely works for tiny quantum particles like electrons and photons, but not for macroscopic objects like cats. When we observe or measure a quantum system, the superposition collapses into one definite reality. This thought experiment continues to spark debates about the nature of reality, the role of observation, and the boundary between the quantum and classical worlds. It reminds us just how strange and counterintuitive the quantum realm truly is.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.